Thank you for joining me. This is screencast number 2 for Unit 3, Lesson 3. And we're going to start on page 141. And don't worry, I know I forgot to show you guys the highlights on page 140. I will do that with this screencast at the end. All right, so page 141. Bohr models show atoms' electrons organized into energy levels. Each energy level can hold a specific number of electrons. The first energy level can hold up to 2 electrons and is the one that's filled first. The second energy level can hold up to 8 electrons. Many atoms have additional energy levels. Energy levels are usually not added. Start adding anything to the higher energy levels. The energy level shown from the nucleus in the Bohr model is called the outermost energy level. Electrons found in the outermost energy level of an atom's Bohr model are called valence electrons. Different atoms have different numbers of valence electrons. Okay, the Bohr model above shows how the electrons in an oxygen atom can be organized into energy levels. An oxygen atom has 8 electrons, 2 in the first energy level and 6 go in the second. In the Bohr model of an oxygen atom, the second energy level is the outermost, so oxygen has 6 valence electrons. Okay, you guys have already actually filled in RM23, which is where you had to determine the number of valence electrons for, I think it was like the first 17 or 18 elements. So you've actually already done this, it's just you haven't actually drawn the Bohr model, which is the next step that we're going to take. Okay, so on number 12, a fluorine atom has 9 electrons. Draw a Bohr model to determine how many valence electrons the atom has. Step 1 is to add 2 electrons to the first energy level. Okay? If I had a total of 9 electrons and I've added 2, the answer to B, how many electrons do I still need to add? That's 7 more electrons that I need to take care of. So I go to step 2. Add the remaining electrons to the second energy level. How many valence electrons does fluorine have? Well, the second energy level is also the outermost energy level for fluorine, and there are 7 electrons there, so fluorine has 7 valence electrons. I'm now on page 142. How does the periodic table show the number of valence electrons? You can determine the number of electrons and valence electrons in an atom of an element without a Bohr model. Just use the periodic table. The atomic number of an element listed in the element square of the periodic table gives the number of protons in each atom of that element. Neutral atoms have equal numbers of protons and electrons. So the number of electrons in a neutral atom is also equal to the atomic number. Remember, that's our ape-man mnemonic, because atomic number equals the number of protons, and if it's neutral, it also equals the number of electrons. Elements in the same group or vertical column have the same number of valence electrons. You can use the group number to find the number of valence electrons in groups 1 and 2 and 13 through 18 as shown below. There is no simple rule to find the valence electrons in groups 3 through 12. Groups 3 through 12, guys, are the transition metals, and they use 4 energy levels, so that's where things get more complicated. And remember, we're going to pay most of our attention to elements 1 through 20. Potassium and calcium are elements 19 and 20, and they actually have 1 or 2 valence electrons in the 4th energy level, and those aren't too complicated to figure out what to do with. But then once we get to element 21, which is scandium, then things are a little less predictable. And like I said days ago, that's something that we're not going to cover in 8th grade. It's not that we can't figure it out, it's just that's beyond the scope of what we're going to be doing. Okay, so that's something you'll learn about in chemistry. All right, but back to what we were talking about. You can use the group number to find the number of valence electrons in groups 1, 2, and 13 through 18. Remember, groups 13 through 18 are sometimes referred to as 3A through 8A. Okay? The atoms of elements in the last group of the periodic table, group 18, otherwise known as group 8A, have a full outermost energy level. Helium only has 2 valence electrons in its first and only energy level, and that's why it's placed over with the rest of the noble gases, because it has a full outer shell of electrons. Okay? All of the atoms of the other elements in group 18 have 8 valence electrons. These atoms are non-reactive and do not tend to form bonds, so they are rarely involved in chemical changes. Almost all atoms of other elements readily form chemical bonds. Okay? So group 18, helium, neon, argon, krypton, xenon, and radon, you're not going to see those written in chemical reactions because they don't react with anything. They don't need to react with anything because they already have a full outer shell of electrons. Okay? So let's talk about why other atoms do form bonds. So now I'm on page 143. An atom tends to form bonds if its outermost energy level is not full. Atoms that have fewer than 8 valence electrons, with the exception of helium, do not have a full outermost energy level. These atoms gain, lose, or share valence electrons to form bonds. When atoms form bonds, their outermost energy levels may be filled. For example, a chlorine atom has 7 valence electrons. One more electron would fill its outermost energy level. A chlorine atom can gain 1 electron from a sodium atom, for instance. When this happens, the chlorine atom has 1 more negatively charged electron than it has positively charged protons. The atom becomes a negative ion because it gained a negative charge. It gained an electron. An ion, remember, is a charged particle that forms when a neutral atom either gains or loses an electron, or more than 1 electron. The sodium atom loses an electron and becomes a positive charge. It lost a negative, so now there's more protons than there are electrons. These ions both have 8 valence electrons. So if you think about sodium, which is down there actually in the number 16, visualize it. If you look at Na for sodium, you'll notice that it only has 1 valence electron in its outermost energy level. And if you look at chlorine, it has 7. Well, if sodium gives up its 1 valence electron to chlorine, well, now chlorine has 8 valence electrons in its outermost energy level, and sodium has given up its 1, and so now its outermost energy level is that second energy level that has 8, so it's much more stable. Okay? So these ions both have 8 valence electrons now that they do that. Their outermost energy levels are full. Bonds hold the negative and positive ions together, and the resulting substance is sodium chloride, which is also known as table salt. And like I said in the last screencast, please keep in mind that the chemical properties of table salt, sodium chloride, are completely different than the chemical properties of sodium metal by itself or chlorine gas by itself. Okay? All right, I'm going to go back and I'm going to show you what I highlighted and made notes of from page 140 to 143. Okay, on page 140, I highlighted the information about the different types of models, and I went back and labeled them: electron cloud model, Bohr model, and space filling model. And then on page 141, Bohr models show atoms' electrons organized into energy levels. Each energy level can hold a specific number of electrons. Remember that the first energy level can hold 2, the second energy level can hold 8, and actually the third energy level can also hold 8. Okay? Electrons are not usually added to energy levels until the lower levels are filled. The energy level shown furthest from the nucleus in the Bohr model is called the outermost energy level, and electrons found in the outermost energy level of an atom's Bohr model are called valence electrons. Okay? And I wrote down again and highlighted it. I hope it's not hard to read. It says valence electrons are the only electrons involved in chemical bonding. Okay, I am on page 142, and I've got that page highlighted, and then we'll look at page 143 in just a minute. On page 142, under how does the periodic table show the number of valence electrons, find the sentence that says elements in the same group or vertical column have the same number of valence electrons. You can use the group number to find the number of valence electrons in groups 1, 2, and 13 through 18, as shown below. There is no simple rule, however, to find the number of valence electrons in groups 3 through 12. And all of the elements that you're going to find valence electrons for are in the taller columns, and those are simpler. And then once you get into the larger atoms, remember we're not going to do those as 8th graders anyway. You'll learn how to do some of that in chemistry. Okay, but if you do look down at the bottom of page 142, if you notice I have marked over the top of the columns, over column 1 or group 1, I put 1 VE, meaning it has 1 valence electron. At the top of column 2, I put 2 VE, 2 valence electrons. At the top of column 13, that column is sometimes known as 3A, 3 valence electrons. Above column 14, 4 valence electrons, 5, 6, 7, and 8 valence electrons for column 18, except for helium, because remember helium has a full outer shell of electrons, but it only uses the first energy level, so it only has 2. And then the short columns, I put a bracket around those and just reminded you that there's no simple rule for telling the number of valence electrons on those, so that's something that we will save for actual chemistry class and we won't do in here. Okay. Down at the bottom for number 14, how many valence electrons does nitrogen and phosphorus both have? Nitrogen and phosphorus are both in the same column, the same group or family. Okay. So nitrogen has 5 valence electrons and so does phosphorus. And remember that elements in the same column have similar properties because they have the same number of valence electrons. And that's what this says down here at the bottom. Okay, so then we're going to go on to page 143 and look at that. All right, I am now on page 143. Why do atoms form bonds? An atom tends to form bonds if its outermost energy level is not full. Skipping down a sentence or two, these atoms gain, lose, or share valence electrons to form bonds. And then down further in the second paragraph, find the sentence that says an ion is a charged particle that forms when a neutral atom gains or loses an electron, or several electrons. Okay? A neutral atom means it has no overall charge, so a neutral atom is going to have the same number of protons as it has electrons. But an ion has either more protons than electrons, or it has more electrons than protons. If you will look over there on the right-hand side, when you gain electrons, when you gain little negatively charged electrons, the atom becomes a negative ion, and those ions are called anions. If an atom loses electrons, it loses negative charges, and it becomes a positive ion because now it has more protons than it has electrons. Okay? And if it loses electrons, it's going to be a positive ion known as a cation. Number 16, it says, compare in the space below each Bohr model. Write the number of valence electrons that each atom has. Hydrogen has 1. Neon has 8. Sodium has 1. Helium has 2. Carbon has 4. Chlorine has 7. And then on number 17, it says, circle the atoms that are likely to form chemical bonds with other atoms. All of them are likely to form chemical bonds with other atoms except for neon and helium. Neon because it has a full outer shell of electrons, because the second energy level can hold 8 electrons, and that's how many it has. Helium also is not going to undergo chemical bonding because it has a full outer shell of electrons. The only energy level that it uses is the first energy level, and it can hold 2 electrons, and it already has the 2 electrons, so it will not form bonds.